Hi everyone, welcome again to this channel. Today we are going to talk about streaming telemetry again. I know it's a fascinating topic. One of the labs that we've built in the past, the Linux Streaming Telemetry Lab, is one of the most liked repositories we have ever created. So definitely there's a lot of interest in the observability, operations, streaming telemetry in general. So we will talk about this again, but with a more kind of interesting, from a very interesting angle, I should say. Now, what you're looking at is Grafana dashboard that collects some metrics from, in this particular case, from leaf 1, as we see here. Now, if we look at this dashboard, what we see is kind of node scoped metrics, how many peers it has, how many routes it has, active, installed, all that jazz. But we also see the services that are configured on this node, right? And from the network perspective, you do not really care about a single particular node in your network. You care about the services that you offer. You either offer it to your compute team or you consume the services yourself, but it's never a single node health that you really care about. You care about the network-wide health of your service. Is your VNet for your GPUs is operating well and healthy? Or can your customers connected to your MAC-VRF can still pass traffic, and is this service healthy? Now, the reason I'm bringing this up is that if you look at this dashboard, you see that my leaf 1 reports that all of its services, MAC-VRF 201, 202, IPVRF, they're all up and green. It's all kind of dandy. But the problem is that this health metric does not mean anything for the network-wide service delivery. Because what you can see here, we have some, problems with our lags. And if we scroll all the way up, we will actually see that our service, IPVRF and MAC-VRF, they really are not healthy. They are degraded. And the reason is that on leaf 1, I have 4 interfaces in up or down state. Now, you do not see this when you are looking at the services on my leaf 1. We just looked at it and we saw it all green. And the problem is that without having this network-wide visibility provided by the streaming telemetry and your, collector capabilities, you cannot really know if your services are operational or not. But how do we get this aggregated level for the services here? Because it's not node specific, it's network wide. It basically says if my IPVRF that I have configured in my network healthy or not. Is it degraded? Is it up or down? And what is also interesting here is that we have the fabric health here as well. You see this kind of yellowish color here associated with the value 75. That is because my fabric is not 100% healthy. How do I know that? How do I collect this network-wide metric? How do I attach it to, a percentage of the healthiness? This is going to be a topic of today, and I will show you how you can deploy this lab in its entirety with just one click on any compute that can run containers. Let's go. So it all starts with the repository. At Nokia EDA, we like to build in the open. That is why our labs are in a public domain. You can go to github.com/EDALabs, EDA Telemetry Lab, and you will see a repository that contains all artifacts that you would need to build up this lab. So now I have cloned my repository, right? EDA Telemetry Lab has been cloned to my machine, and the prerequisite is that you have EDA already installed. Now, we had numerous videos on how you can install EDA on any compute. You don't need to have any specific knowledge how to install a platform. You don't have to have a license. You don't have to call us. Just go to docs.eda.dev and you will see the getting started page that explains how you can install EDA with just one make command, maybe 2. And then once you have it running, what it takes to bring up this lab is just one command. When you clone the repository, you checked in the EDA Telemetry Lab directory, and all you need to do is you need to provide the URL of your EDA system and call the init shell script. Now, the EDA URL in my case has a domain name associated with it. In your case, it can be an IP address, and if you need to add a port, you will just put it here as well. So I have it on 443 port, that is why I don't need it here. But yeah, that's all it takes, really. So let's run. So now we start to build up the lab, build up the topology that is required for this particular use case. But I will show you how these components actually fit together. So if you go to the repository, it has this nice diagram that explains what you get when you install this lab and deploy it. So we have this Kubernetes cluster that comes with EDA installation, right? That's the platform that we build on top. And inside this Kubernetes cluster that EDA installs for you when you do this getting started guide for EDA, you will have the EDA installed with a digital twin in it. So we will deploy the topology inside our Kubernetes platform, inside or next to EDA, so you don't really have to deploy it elsewhere. It will be just packaged neatly in one single component that you install with one command that we just launch in our terminals. Now, inside this Nokia EDA ecosystem, you will have your digital twin, right, with the leaf and spine switches, but you also will have servers. And on these servers that are emulated with Linux containers, we will run iPerf to push some traffic and see how metrics are reacting to that. What is critical here is that the Nokia EDA system that's in the picture is not for just the digital twin part. The reason that we bring it up here in this lab is because EDA is the source of truth for all the metrics and all the telemetry stuff that we will push to the upstream consumers like Prometheus, Kafka, Loki, etc., etc. So in this case, it's not GNMIC that is now connecting to individual nodes. It's EDA that manages the fabric, already knows how to connect to all the nodes. It has all the credentials. It has the capabilities to subscribe to the leaves on demand. All that good jazz is kind of coming with the platform. All we have to do here is we have to install these two applications, Kafka Exporter and Prometheus Exporter, and export the metrics that EDA has access to these upstream consumers. Because if we want to ship metrics from within the EDA platform to something else, like, for example, Prometheus database that we have in our lab, we will configure the Prometheus exporter and we will say what metrics from EDA we want to ship to Prometheus. And Prometheus will scrape the endpoint and get the data out of it. So that's how it works, right? The EDA manages the platform, meaning your data center fabric. It gets all the telemetry information from the nodes for its own operation. But then you can install these two apps that are provided by Nokia, and these apps will be able to get this data from the EDA platform and ship it upstream. Okay, so that's cool. So what we get in the lab as well, besides this digital twin with 4 leaves, 2 spines, we get this full telemetry stack as well. We get the Grafana, we get the Prometheus database, we get the Kafka broker, we get the Alloy for our telemetry ingester, we get Loki for log aggregation, storage, and processing. It's all packaged in one lab delivery. And because we leverage Kubernetes, it's all kind of natively installed on the platform. We did not create any custom stuff. If you have any other Kubernetes cluster, you can install it there as well as easily. From the UI perspective, you will have the Grafana dashboard, of course. We ship the Grafana dashboard with the lab. You get the drill. It's all packaged, right? But I wanted to show you something regarding the services. Because EDA is there as the main kind of point for all of the tools to talk to and get the data out. This is what really happens. So EDA kind of maintains all the state for your network, and it manages the network. It configures the fabric and VNets and MAC verbs and IP verbs. And then with these two applications, Prometheus Exporter and Kafka Exporter, it exports kind of two category of things. Your regular metrics like CPU counters, the health of your fabric, like some integers or floating point numbers, they are exposed to Prometheus. And Prometheus stores them, and then Grafana can display the data with PromQL queries. For something that is not kind of the metrics in nature, meaning deviations, alarms, we use Kafka. So we can export arbitrarily data to put it on a Kafka bus, and then from Kafka, Alloy can source this data in and put it to Loki so that we can have the alarms in the same UI, and you will see how it works. And lastly, what I wanted to show you is that the service composition that we have in this lab is pretty straightforward. We have kind of like one layer 3 service and we have a layer 2 service. What you see here is that there is a layer 3 VPN with 2 subnets connected and a layer 2 VPN with just like one, of course, subnet, and servers are connected to them through different VLANs. So you see these 4 servers that we had, they kind of broke down to 2 different customers, if you will. So one customer is connected to the L3 VPN, the other customer is connected to L2 VPN, and based on the VLAN numbers, they are attached to different services. So again, this is to showcase how you can configure the services, not just, connect servers to a raw IP network and call it a day. No, we wanted it to be more or less real. That is why you see it here, that we have proper overlay services running on top of our EVPN VXLAN fabric. And of course, if you want to dive deeper, here's like a breakdown how we actually connect these containers together and how they map to the services in a more kind of network engineering way. A very nice diagram. I love it. We also have this traffic generators, right? And you will see how it works. We want to push some traffic and see how the metrics react into that. Okay, so let's see if we have our installation complete. Okay, so it's actually, it's only 2 minutes and you have the full lab up and running. And by the end of this installation script, you will see 3 URLs provided to you to access the Grafana, the Prometheus UI, and the control panel. Now, let's start with Grafana UI. So I click on this link, the Grafana panel opens up, and you see the same picture that we started this video with, right? You see this Grafana dashboard with our fabric. You see the ports being light green that are operational. Our EDA is subscribing to all of these metrics, and we expose them through Prometheus exporter to Prometheus, and Grafana is displaying this to you. The interesting piece here, and I will emphasize it here once again, is the network-wide health state that we see here. Now our fabric health is 100%. Like, what is a fabric? Like, if you did not really follow EDA's videos before, you probably don't know what a fabric is, and the term might be confusing. In our case, what fabric is a resource that we create in EDA that declaratively defines the state of your fabric and, of course, configures it on your switches. But what fabric entails is the IP configuration on all of the leaves and spine switches, the interswitch link configuration, is it BGP unnumbered, is it V6 numbered, things like that. The overlay and underlay protocols, that do we use single eBGP for overlay and underlay, or do we split and mix and match? So everything that is related to creating the fabric that is ready to onboard the overlay services, that is what is driven by the fabric resource. And when we create this, our fabric has health that is associated with it. Something that is very unique to EDA is that we are acknowledging that there is this great divide between the configuration tools and state/monitoring tools. We know all too well this different set of technologies that help us configure the network and then monitor and kind of observe the network. And while it's good to have a choice, it's not always feasible to have this disparity between the tools that are doing the configuration and the monitoring. And the main reason is because if you configure something with one tool, and this configuration is a network-wide entity like a fabric or a service, how do you tie the state back to this intent back, right? How do you say when your Nornir script configured 500 VRFs or VLANs across your network, how do you associate a health for your newly provisioned service? You cannot, right? You definitely have to do some legwork to make it work. You need to collect all of the metrics from all of the individual components with a different tool without really knowing what was the high-level input to your configuration system to associate this state back to the configuration resource that you created with your automation. And with EDA, we are trying to solve that by adding state to the configuration intents. Let me show you what I mean. So now I'm logged into my EDA system. We are looking at the main dashboard and we are seeing this EDA telemetry namespace that our installation of the lab created for us. We have these 6 nodes, 4 leaves, 2 spines, a good number of interfaces, and then some ambient traffic passing by. What I wanted to show you is if you go to the Fabric application and you see the fabric that we just created, right? We, as I mentioned, we associate state to the configuration intent. This configuration intent said that we want to configure a fabric, and this is the spec of the fabric with these interswitch links with these leaves and these spines, and we will use the eBGP overlay protocol for overlay and underlay protocol. So this was our configuration intent. But besides the configuration intent, we also associate a state with this. This is what you see here in the status field, right? We know how to calculate the health score of a fabric, and here it says 100. And we also give you a health score reason why it is healthy. That is because we know that all the interswitch links are healthy, all the default VRFs that are making up this fabric are healthy. And because all of these subcomponents are operational and healthy, only then we can say that the fabric is healthy as well. If that does not make sense, let me show you one cool trick. If you go to the transactions, so there is my fabric, right? If I display the topology of this transaction, you will see what EDA actually does when it creates a particular resource. So here is my fabric resource, right? That is the intent that I gave to the system to configure a fabric on top of my leaf and spine switches. This intent created a lot of children objects. It created these ISLs, the BGP groups, the system interface, and they in their turn created other children resources. And you see how it all kind of goes down the right path from the high level abstracted input to more like child resources. And we know the state that is associated with all of these resources that you see on this transaction topology graph view. And whenever something changes, we recalculate in concurrent fashion all of the state of the subcomponents of a fabric, and that is how we can drive back the health of something as network-wide as a fabric back to, calculate it all from the subcomponents and drive it back to the original fabric intent. So now that we know how things are mapping together and how we are calculating this aggregate state for services and fabrics, our network-wide resources, let's see how we can make it more, interesting and live. First, I want to start some traffic because currently we have some ambient management traffic between the interfaces. Nothing too fancy, nothing to look at. So let's go to our lab directory and start some traffic. Right. So in our directory with our cloned lab, to start the traffic, all we need to do is call one script. CX traffic shell script start all. That will start the traffic from all the servers. So I'm starting this one. It will go and connect to my simulated Linux servers, and it will instruct them to start pushing some traffic. Back to our dashboard, you can see how we start to see this links getting some nice orange and yellow color based on the traffic load that is passing through them. You see how we are load balancing in our overlay. We occupying, or we kind of saturating all of the links. eCMP is working fine. And of course, we see some fabric throughput that is being shown to us here. It's all, as I mentioned, it's all coming through EDA. So EDA creates the Prometheus scraping endpoint based on the Prometheus exporter application configuration. And based on that, our Prometheus database that is part of the lab connects to the scraping endpoint, gets this data out, and you of course can just open this up, see the actual expression, explore the metrics. Like there is nothing artificial here. It's all working live, and you will have the same lab running on your compute as easily. Now, traffic is passing, it's all great, but now we want to simulate some disaster recovery scheme, or maybe just to simulate some bad actor messing up with our network and see how the operational dashboard can help us with it. Now, to do that, you can, of course, connect to the nodes. In our documentation, we show you the CLI command that you can connect to your either servers or leaf and spine switches. Very easy. Just give them a name and you will be in the shell momentarily. But your lab also have a control panel. So the control panel that was presented to you here at the end of the lab deployment is a nice way to mess with your interfaces. It's a simple Nginx web UI service that uses JSON RPC to talk to Astro Linux devices and shut the ports down, right? So let's say I want to shut down my port leaf1 E11. So I select these two guys and say shut down. The JSON RPC call is being sent out to my nodes. And if I go back here, let's have a look. So this one should go red momentarily. Okay, now it's done. So this port has been disabled. And because we disabled this port, nothing really happens to our traffic, because we're just using the other link. We saturate it more. The traffic is still passing. But see here, we have now these services being shown as degraded. We know that because we shut down one of the ports on the leaf that are in the direction of the edge of the service is not as healthy anymore, right? It's now degraded, and you see how it's reported back to you. The reason that we are able to report this service health back to you is because EDA calculates all of the subcomponents, as I mentioned before, and I will repeat it again. We calculate the health of all of the subcomponents of the service as well. And whenever something is going down or is not operational anymore, we will bubble this up to the kind of the mother service, the actual IP verb from MacVerb that relies on the subcomponent. So that is why you see it here degraded. And again, without seeing this, yeah, you will be able to see one port going down on one leaf, but how do you know if it's affecting a service that you are interested in? Without having this network-wide visibility, you'll really kind of gear yourself for more work or even not being able to detect things as easily. All right, so that's great. You can play with this. You can, shut down ports here and there, but we also have this logs and alarms, right? Because we use this Kafka exporter and we can ship things over to Loki and display it in the same Grafana dashboard, it's really nice and easy to see how many alarms we had, when they happened, and you can also correlate it as easily within your timeline, right? So we have here some alarms that we can look at. The alarms are here in the list, so we can open them up, see the description, what happened, what path was affected by this alarm, etc., etc. So it's kind of a very nice single pane of glass towards your fabric that you are managing. In this case, it's a data center fabric. But yeah, you can see how this can be useful for some overseeing dashboards that you can use. We also display you the deviations, right? The deviation really quickly. We're not stopping on the EDA concepts here as much. The deviation happens when something configures something on the node, and this goes against the intent that is being configured in the EDA system. So in EDA, we wanted to have all the interfaces up and running, but then somebody, in our case, the control panel script, went to the CLI of the Astro Linux Leaf 1 and shut down Ethernet port 1.1. That is a deviation. So we can see it here. It will show you some details, right? The intended values, admin state enable, the running value, admin state disable, a deviation. We can discard it, of course. I will leave it here. It's not the point it's not the point here. We can also see here the node level stats. You still want to have like this node level visibility. You can switch between the fabric nodes and you will see different view, of course, based on your selection. And we also have these logs, right? So we have the login configured on our systems, and Astro Linux switches using syslog. They ship the syslogs not to EDA. This is not where EDA is actually in the picture. These syslogs are going directly to Alloy. This is how we ship these syslog messages to Alloy, and then Loki gets the parsed log messages from Loki from Alloy to Loki. It's all kind of well explained in the documentation that comes with the lab. But you see here that you can look at the logs. We have the all of them here categorized by the app, so you can select more of them, or choose which application logs you wanna browse specifically. Let's see how we can affect the fabric health, because currently we shut down one of the access ports, and the access port is not part of the fabric. That is why the fabric health says I'm 100% green, all good. But what if we shut down some, let's say Ethernet 149 on leaf 2, this is the leaf to spine interface, and we also shut down this guy as well. So now we shut down 2 interfaces on leaf 2. Well, 49 is already down, the 50 is going to be down momentarily. Okay, now we affected the fabric. Now the fabric knows that, oh my god, I'm not healthy anymore because my interswitch links are not operational anymore. And you see how here we transition from happy green to not so happy yellow. And this will give you an ability to kind of look at the fabric state network-wide without really going on and dig into your individual leafs here. And you can see how, of course, when you have hundreds of leaf switches, it will be not practical to actually go and see each one of them and react to some alarms that you will have configured with Alarm Manager. Having this visibility here on the dashboard network-wide is very important. I would say very valuable to the operational teams. They would want to have something like this without writing super complex PromptQL expressions. We do the legwork here. We calculate the health score and we present it to Prometheus and Grafana. We do not calculate this in Grafana or Prometheus. It's all this kind of the health metric strictly coming up from EDA. And because EDA knows what makes up a service or a fabric, we know how to calculate the aggregate score. So I hope this lab would be useful for you to understand what is possible in the operational realm and how EDA can help you enhance the visibility of your fabric on the network-wide scope. And of course, please check out this repository. It's all free. You don't have to have a license. You don't have to call us, write us. Just, clone the repository, install EDA, all free, and play with it and see how it works. I hope you like it. You will find a lot of more interesting details in the description to this video. And let's connect in our Discord, eda.dev/Discord. We're all here. See you next time.